Hello everyone. This section we are going to discuss about problems on movements of a random variable. Myself, Dr. G. Karthik Reddy, working as Associate Professor in the Department of EC, MLR Institute of Technology, Hyderabad. And today's concept says we are going to discuss the problems based on movement about origin and movement about mean. Okay, we already discussed in the previous session about the definition of movement about origin. Okay, this is the definition about movement about origin. Expectation of x power n equal to integration minus infinity infinity x power n small fx of x dx. Okay, we'll discuss the problem. For example, if x is a discrete random variable, then what you are having? Okay, this is x, this is p of x. Okay, you are having some instance 0, 1, 2, 3, 4. Okay, each one having to get the probability of getting 0 is, for example, 1 by 6. Probability of getting 1 is 2 by 6. Okay, example, if you are taking the, okay, we'll take the 5 up to 0 to 5 instance we'll take. Okay, next this is 3 by 6, this is 2 by 6. This is 1 by 6, this is 2 by 6. Okay, for example, if you are taking like this. Okay, now next, what is the expectation of x? Expectation of x is equal to summation I equal to 1 to n. Here n is what? N is a number of random values. Okay, here how many random values you have? 1, 2, 3, 4, 5, 6. N equal to 6. Now xi into p of xi. Now you have to take all the values. 0 into 1 by 6 plus 1 into 2 by 6 plus 2 into 3 by 6 plus 3 into 2 by 6, next 4 into 1 by 6 plus 5 into 2 by 6. Okay, then you do the calculation part. 0, 2 by 6, here what you are having? 6 by 6, next here you are having 6 by 6, next you are having 4 by 6, next you are having 10 by 6. Okay, then what you are having? 10, 14, 20, 26, 28. 28 by 6. Okay, 28 by 6, you will get approximately 4.25 something you are going to get. This is the answer for this expectation of particular random. For example, same example we will do in a similar different manner. Okay, if you are having tossing a when rolling a die, when you roll a die, what is the values you are going to get? Okay, x is a random variable of a particular what is that? Rolling a die. Rolling a die, what are the possible outcomes you are going to get? 1 to 6. You consider that 1, 2, 3, 4, 5, 6. When you roll a die, getting a number 1, okay, getting a number 1 is what is that? Probability of event. Particular event is getting a number 1. Is number of favorable outcomes. What is the number of favorable outcomes? Only one outcome, 1C1 by 6C1, 1 by 6. Okay, similarly, if you are getting for, if you want to get the number 2 from a rolling a die, okay, what you are going to get? 1 by 6 only. Okay, in all the cases, you will get 1 by 6 only. Then again, same, you are going to calculate. This is a discrete instance. We are taking from 1 to 6. Then expectation of x is equal to, again, summation I equal to 1 to n equal to 6, xi into p of xi. Okay, you take all the values, multiply it. 1 into 1 by 6, 2 into 1 by 6, 3 into 1 by 6, plus 4 into 1 by 6, plus 5 into 1 by 6, plus 6 into 1 by 6. Then what you are going to get? The summation of all those things. 1 by 6, 2 by 6, 3 by 6, 4 by 6, 5 by 6, 6 by 6. 6, 5, 11, 11, 4, 15, 15, 3, 18, 18, 2, 20, 21 by 6. Okay, this is for expectation. Now, if you want to calculate mean square value, we are discussing about movement about origin. Movement about origin, you are having the mean square value also. Okay, then what you are going to get? Summation. Summation I equal to 1 to n, here n equal to 6, xi square p of xi. N equal to 6 because you are having the, when you roll a die, how many possible outcomes you are going to get? 6. 1 to 6. Okay, now what you are going to get? Okay, so again you multiply it. 1 square into 1 by 6 plus 2 square into 1 by 6 plus 3 square into 1 by 6. Next 4 square into 1 by 6. 5 square into 1 by 6. 6 square into 1 by 6. Then what you are going to get? Here the values. Calculate it. 1 by 6 plus 4 by 6 plus 9 by 6 plus 16 by 6 plus 25 by 6 plus 36 by 6. You sum all these terms, then what you are going to get? 25 plus 36, 61, 61, 67, 77, 77, 9, 86, 90, 91 by 6. Okay, this is the way you have to calculate mean square value. Then how to calculate the variance? Variance, okay, variance no need to calculate. Again, you have to keep variance. You are having two formulas. Expectation of x minus x bar whole square. Okay, here mean we calculated. You can substitute that and you can calculate that, or you can also have the calculation mean square minus mean of square. Mean square minus mean of square. Mean square we just now we calculated. You substitute those values, then you will get the variance. Okay, this is one of the example in case of discrete random variables. Okay, if you are taking for a continuous random variable. Continuous random variable, what is the formula? Okay, variance comes under what? Movement about mean, not movement about origin. Because we have formula. Okay, we have already formula. This is a, if n equal to 2, n equal to 2 if you substitute, this is called what? Variance. Okay, this is called variance. N equal to 2 represents variance. Okay, now next, here we will discuss some problems related to this. For example, if you are having the, if x is a, okay, if x is a continuous random variable, if x is a continuous random variable, then the density function. For example, if you are considering the, if x is a continuous random variable with uniform distribution. Okay, with uniform distribution means, what is a uniform distribution tells that, okay, if any x is a random variable, what is uniform? Constant with respect to particular interval. For example, a to b are the two instants which is constant. Okay, then the density function small fx of x which is equal to 1 by b minus a. Okay, we have to calculate the expectation of a uniform random variable. Then what is the definition? Probability density function is equal to 1 by b minus a for the interval a less than or equal to x less than or equal to b. Next 0 otherwise. Means it is valid only between the interval a to b. Then what is the definition of expectation of x? Expectation of x is equal to integration minus infinity to infinity small x into fx of x dx. Here the interval is defined only between the interval a to b. Then this is a integration is defined for minus infinity to infinity. But it is valid only between a to b. Remaining it is 0. Then what you are going to consider? A to b x into what is defined fx of x? Okay, it is defined 1 by b minus a for the interval a to b. Remaining 0. Then you substitute it 1 by b minus a dx. Then what you are going to get? 1 by b minus a is a constant. You are going to get a to b x into dx. Then what you are going to get here? Okay, here what you are substitute here 1 by b minus a, here x square by 2. Okay, b minus a to b. Now substitute what you are going to get. Okay, what you are going to get? B square minus a square by 2 into b minus a. Now you know the formula. You know the formula. What is that? B square minus a square, b minus a into b plus a by 2 into b minus a. B minus a get cancelled. Then what is the expectation? Expectation of a uniform random variable is a plus b by 2. A plus b by 2. Now we are going to discuss about the mean square value. What is the mean square value? Mean square value, you know the definition. Integration minus infinity to infinity x square into fx of x dx. Then what is a uniform random? Here x is a uniform random variable. Then what is the interval it is changed to? A to b x square, here 1 by b minus a dx. Now you have to change it. Now what you are going to get? 1 by b minus a is a constant. Take outside the interval. a to b x square dx. Okay, apply the integration. Then what you are going to get? 1 by b minus a. Here x power 3 by 3 a to b. Now what you are going to get? 1 by 3 into b minus a. Here b power 3 minus a power. Okay, this is in the form of a cube minus b cube or b cube minus a cube formula. You simplify it further. Then what you are going to get formula? 1 by 3 into b minus a. Here b minus a. B square minus ab plus a square. Okay, this one will get cancelled. You will get b square minus ab plus a square by 3. Okay, this is a formula for what? Mean square value. Okay, we completed mean and mean square. Those are related to movement about origin. Now, what is a variance formula? You know it already. What is a variance formula? Okay, what is a variance formula? Variance is equal to mean square minus mean of square. Okay, mean square, just now we have calculated. What is that? B square minus AB plus A square by whatever you got 3. Next here minus A plus B by 2 whole square. Okay, then what you are going to get? You simplify it further. B square minus AB plus A square by 3 minus, here what you are going to get? A square, okay, directly I'll write A square by 4, or otherwise you simplify it, A square plus B square plus 2AB by 4. You simplify it further, you will get A minus B or by whole square by 12, or B minus A whole square by 12, both are same. Okay, this is the formula for variance of a uniform random variable. Okay, variance of a uniform random variable. Okay, if you know the formula of all the density functions are important. Okay, you have to know the formula of density functions of all the all binomial, Poisson. Just now I solved for uniform. Okay, similarly we can also solve for, okay, binomial or Poisson or uniform or exponential or Gaussian or Rayleigh. Okay, these are the 6 examples of distribution and density function. Here the density function of all these 6 examples. Just now I solved for uniform. Okay, uniform we have solved. Similarly, we can solve for remaining density functions. By applying that, we can calculate expectation, mean square value and variance. We can calculate these values of that. Okay, now next we'll do some more examples like variance of some 2x plus 3. Variance of 2x plus 3, we have taken the formula from the property. Variance of kx plus b is equal to k square into variance of x. From this we can calculate it. K square means here 4, 2 square, 4. Okay, then we are going to get 4 into variance of x. Okay, 4 into variance of x. Okay, now next, okay, here we are going to consider that if we are having the variance properties, from the variance properties we can also solve some of the problems related to this. Okay, here we are using, main drawback of this means movement about origin and movement about mean means we have to calculate individually for all the, for movement about origin. For example, if I want to calculate for the up to 5th order movement, we have to apply the integration for each and every, for example, first order movement you have to apply fx of x. Okay, now for second order movement again we have to calculate x square into fx of x. Okay, if you are having third order, again we have to calculate x power 3 into fx of x. Okay, similarly for movement about mean also you have to calculate integration minus infinity x minus mx for up to whatever the order you are going to get, you have to calculate for. Computations are increasing. Okay, computations are increasing. To overcome that, we are using for the next session topic we are going to discuss, that is movement generating function and characteristic function. Okay, these two functions are useful for generating nth order movements in single integral. By using the single integral we are going to calculate, okay, nth order. Okay, here the computation is increasing because we are calculating for each and every movement. Okay, for 0th order, first order, second order, up to nth order we are calculating. Whereas when you are going for taking the function of moment generating or characteristic function, we are taking only single integral. Single integral we are taking to calculate the nth order moment. That we are going to discuss in the next session. Thank you.